Hello everyone. You are welcome to Science Sparkle. Science Sparkle presents CBSE Class 10th Chemistry Metals and Non-Metals. And today we will discuss how do metals and non-metals react. So before going to discuss about the metals and non-metals, how do they react, we have to think about the periodic table. In the periodic table, left hand side, metals are present except hydrogen, and extreme right hand side, inert gases are present, and before the inert gases, non-metals are present. So just you see, when noble gases will think or inert gases will think, except helium, like neon, argon, krypton, xenon, radon, they have 8 electrons in their outermost shell. And helium, it has only one shell and one subshell, so it has 2 electrons and it is inert. If you think about metals, they have 1 or 2 or 3 electrons in their outermost shell. And just before inert gases, the non-metals are present. They have 5 or 6 or 7 electrons in their outermost shell. And totally, if noble gases, metals and non-metals will discuss, will think, noble gases, they are chemically inactive and they have 8 electrons in their outermost shell. So all the metals and all the non-metals, they want to be inert by acquiring the electronic configuration of inert gases. Now metals, they lose electrons and become positive ions, so they are called electropositive elements. For example, sodium, its atomic number is 11, electronic configuration is 281, so it has one valence electron. By losing that electron, it will be uni-electropositive ion. And if you think about non-metals gain electrons and they become negative ions, so they are called electronegative elements. For example, if you think about chlorine, its atomic number is 17, its electronic configuration is 287, and its valence electron 7, number of valence electrons are 7, so it gains 1 electron and forms a chloride ion. So now we will think about the metals and non-metals. How do they react? One example I will give, that is the formation of sodium chloride. So sodium chloride contains sodium and chlorine. Sodium is a metal and chlorine is a non-metal. So just think about sodium. The atomic number of sodium is 11. Its electronic configuration is 281. It has one valence electron and it loses one electron to form Na plus ion. That is a uni-electropositive ion. By losing one electron, it acquires the electronic configuration of nearest noble gas neon. Just you think about chlorine. Atomic number of chlorine is 17. Its electronic configuration is 287. So it has 7 valence electrons. So it gains 1 electron to form Cl minus ion, and hence it acquires the electronic configuration of nearest noble gases argon. When both sodium plus ion and chlorine minus ion, Na plus ion and Cl minus ion, they are closer to each other, both oppositely charged ions attract with each other with a strong electrostatic force of attraction and make a bond, and that bond is called ionic bond, and they form the compound sodium chloride. Okay, that is just you can see the dot diagram and also geometric diagram. See, in dot diagram, what is given? Electron dot diagram. So Na plus and plus Cl minus. Na plus, it has 1 electron in its outermost shell. Cl minus, so Cl, chlorine, it has 7 electrons in its outermost shell. So when sodium will lose that electron, it will give chlorine, and sodium will be uni-electropositive ion, and chlorine will have 8 electrons and will be Cl minus uni-electronegative ion, and they will be closer to each other and will make the bond, ionic bond, and will produce the ionic compound NaCl. And you can write the ionic equation also. Na minus 1 electron, so will be Na plus, and chlorine plus 1 electron will gain 1 electron and will be Cl minus. So Na plus Cl minus will produce Na plus Cl minus, or sodium chloride compound will be formed. And if you will go through the geometric diagram, just to see sodium, its electronic configuration is 281. It has 1 electron in its outermost shell. So it has 3 cells. First cell 2 electron, second cell 8 electron, and third cell only 1 electron. If you go through chlorine, it has also 3 cells. First cell 2 electron, second cell 8 electron, and third cell 7 electron. So it has the electronic configuration 287. And the electron from sodium, valence electron, is donated to chlorine, so that sodium acquires the electronic configuration of neon, like electronic configuration 28, and simultaneously chlorine got the electronic configuration 288, and it is being Cl minus. So that is the formation of sodium chloride compound. Now, and that is the ionic compound. So now the question is coming, what is ionic compound, or what is the electrovalent compound? So ionic compounds are called electrovalent compounds because electrons are exchanged. And ionic compound, why it is called ionic compound? Because ions are formed. So ionic compounds are compounds formed by the transfer of electrons from metals to a non-metal. And the compounds which are formed by ionic bond are called ionic compounds. The bonds are called ionic bonds and the compounds are called ionic compounds. Now we will discuss about the properties of ionic compounds. First, ionic compounds are formed by the transfer of electrons from metal to non-metals and are made up of ions. Second, they are crystalline solids. If it is doubt to you, you will keep in mind sodium chloride as the ionic compound and you will think about the properties of sodium chloride. Sodium chloride, that is the salt, it is a solid. So ionic compounds are crystalline solids. Ionic compounds have high melting points and boiling points. Sodium chloride is soluble in water, you can write. So ionic compounds are soluble in water, but they are insoluble in organic solvent like petrol, kerosene, or etc. And the next, ionic compounds, they conduct electricity in their molten state or in a solution. But generally, ionic compounds are crystal solids. If you take, they do not conduct electricity, but they are solutions conduct electricity. Now, after ionic compounds, we will go through corrosion. What is corrosion? Corrosion is the damage caused to metals due to the reaction of metals with oxygen, moisture, or carbon dioxide, or etc., or air. Okay, for example, formation of a brown coating of a rust over iron, that is called rusting. Rusts are formed, that is also corrosion. Second example, formation of a green coating of a basic copper carbonate over copper. Third example, formation of a black coating of a silver sulfide over silver, that is also corrosion. Okay, now how to know, how to test? Now we have to go to show that air and moisture are necessary for the rusting of iron. So what are essential for the rusting of, for the corrosion, and the rusting of iron is another one example of a corrosion. So we have to show air and moisture are necessary for the rusting of iron. For that, first we'll take 3 test tubes, test tube 1, test tube 2 and test tube 3, and again 3 nails, iron nail, each and every iron nail will be dipped in 3 test tubes. And first test tube we have to keep it dry, and better we have to add there some calcium chloride, so which is acting as the drying agent, so it will absorb the moisture. So if any moisture will be there in the test tube, it will absorb. So in the first test tube, calcium chloride and iron nail is taken. In its second test tube, some distilled water is taken, and that distilled water is boiled distilled water, so the dissolved air will be released, and above that some oil will be added, so it will prevent the air to come inside the test tube. Third test tube will add generally some water. Okay, and cork the 3 test tubes and leave for few days, or 1 day or 2 days. And now we'll check the nails in test tube 1 does not get rusted because it had only air and no water, because what waters are there, that was absorbed by calcium chloride, which is the drying agent. Second test tube does not rust because it had no air, it had only water, because it is cooked, and also oil was on the top. And third test tube, the nail in the test tube 3 is rusted because it had air and water. Okay, and you can see this is the figure here. First test tube, second test tube, third test tube. So first test tube there is no rust, second test tube there is no rust, but third test tube it is rusted. And if you take the solution of sodium chloride, it will be more rusty. Now, how to prevent the corrosion? The corrosion of metals can be prevented by applying oil or grease, or applying paint, or by galvanizing, or by tanning, or by electroplating, or by alloying. So what is galvanization? And the coating of zinc. The molten zinc will be taken, and any metal will be dipped inside, and it will be cooled, so the zinc will be coated on the surface of a metal, that is called galvanization. And coating of a tin also, that is called tanning. And coating a less reactive metal like chromium, so on the surface of other metal, that is called electroplating. And what is alloying? So alloy is a homogeneous mixture of metal with other metals or non-metals. So whenever we will make the alloy, it is very hard, and also it will prevent the rusting. For example, steel is the mixture of iron and carbon. Stainless steel is the mixture of iron, carbon, cobalt and nickel. Brass, it is the mixture of copper and zinc. Bronze, it is the mixture of copper and tin. And solder, it is the mixture of lead, tin. So you know, soldering we are saying, so it is used for welding electrical wires together. And if one of the metal in an alloy is mercury, that is called amalgam. Okay, thank you very much for watching this video. I request you all, please like, subscribe and share Science Crackle for next videos to watch first. Thank you.